Good morning, everybody. Today I'm going to give a little talk about DNS cache poisoners. The motivation for this began almost a year ago when the SANS Internet Storm Center reported that there was an ongoing DNS cache poisoning attack. And there's a couple of URLs there for your reference if you want to look up the background on those. The basics of the attack were that some name servers had been poisoned and they were giving out bogus NS records for the comm zone. And the folks at SANS ISC had theories that one of the reasons for this may have been as a way to propagate spyware and other things like that. At that time they noted that most of the name server software from Windows, including NT 2000 and 2003, and the semantic firewall products were affected by this vulnerability and this attack. Oh, right. These are now available on the web. Okay. So here's one slide that just sort of describes the DNS cache poisoning attack. An authoritative name server, that is one where queries would normally go for certain names, is intentionally or unintentionally configured to return bogus and out-of-bailiwick NS authority records. And the four following slides have an example of how this looks. A caching name server sends a query to that authoritative name server and gets a response and trusts the bogus referral, and it stores it in the cache. Future queries for names in the poison zone then go to the bogus name server, and that bogus name server returns incorrect answers to queries that it should never even be receiving. So here's an example with dig. You can probably run this command yourself, and you might see the same thing. I ran dig with the trace option for longislandauction.com. And the first response that it shows is the set of name servers that are authoritative for the DNS route. Then it sends a query to one of those. In this case, we got a response from mroot, and mroot says GTLD servers are authoritative for the comm zone. K.gtld servers says auth1, auth2, auth3.ns.sargasso.net are authoritative for longislandauction.com. And then finally, we got a response from auth1.ns.sargasso.net, and we have an A record in the answer. But we also have three NS records that show, they list themselves, they list the sargasso.net name servers as authoritative for the comm zone. So if this response was received by a vulnerable DNS cache, it would then send future requests for unknown names in .com to one of those name servers. And you can simulate that yourself by, again, using dig. You can send a query, say for www.aol.com to one of those name servers, and you get an answer like this. You get an A record back with 127, 127, 127, which is not particularly useful. And again, you get the authority section says, you know, I am still authoritative for .com. So a little bit about the implementations that are known to be vulnerable. Windows NT is vulnerable to this attack by default. If you have Service Pack 4, you can make it become not vulnerable with a little registry editing pane. With Windows 2000, the early versions were vulnerable by default and later versions were not. Windows 2003 is not vulnerable by default, but it's remarkably easy to make it vulnerable. You just have to go to the properties section of the DNS server and uncheck the box that says protect me from DNS cache poisoning. Semantic, gateway firewall products were vulnerable, and there's a couple of keywords there you can Google for if you're interested in following up on that. So one of the things that I personally wanted to do was I wanted to find out how big is this problem and how many DNS poisoners are out there. So here's the technique that I used. The first and one of the hardest things is to just get a huge list of DNS names. You can go through them one by one, and for each name, discover the set of authoritative servers for the zone. And to do that, my little script sends its own query starting at the root and follows the referrals on down. Once I get the set of all the authoritative name servers, I send a query to each one of those. And in those replies, I compare the NSRR set to the previously learned referrals from the parent zones. And if they don't match, then that's a case of DNS cache poisoning. Now, this technique only finds cases where a parent zone is cached. And at this point, we're sort of only interested in cases where a TLD becomes poisoned, because those are sort of the big targets. So there's a survey, I have a survey that I started earlier this month, and it's actually still running. The input list is a little more than 6 million names captured from various name servers that we have access to. And in those, so far we've found 284 sources of poison. These are the ones that return incorrect referrals to top-level domain or to the root zone. This little table shows which zones are being poisoned or attempting to be poisoned. The most common one is the root zone itself with 217, and then, not surprisingly, c.com, .net, .org, and so on. And there's actually one case where someone is returning a bad referral to a TLD called default, which for most people does not exist, although it's sort of an interesting way to perhaps capture traffic for a TLD that, that people may be using, but that's not officially sanctioned. If you added these numbers up, you'd get more than 284, because some name servers poison more than one zone. Here's a list of a few of the poisoners that we found. And when you read through this list, something becomes sort of immediately apparent, that a lot of these names make you think that they're sort of in the business of the DNS. We have internick, afternick, directnick, domains are free, my name server, expired domain services, DNS made easy, and so on. Some of them, it's not so clear that they're in the DNS business, but by far most of them are. And by the way, at the end of this talk, I'll give you a URL where you can go to our database, and you can sort of browse the list of poisoners yourself and explore it and find more interesting things. So, as I already mentioned, a lot of these poisoning name servers appear to be companies that are in the DNS business, registrars and resellers and perhaps speculators and typo profiteers. Others appear to be companies that are unrelated to the DNS business. Certainly those that are in the business of handling domain names, they should know better than this, and you would hope that they would be able to configure their own name servers correctly and properly so that this kind of thing doesn't happen. Another thing that becomes obvious is a lot of the names that lead to the poisoning authoritative name servers are names that have been expired or have been parked, recently registered, but not yet placed exactly in service. And by the way, I forgot to put this number on the slide, but for the 284 poisoning name servers that we found, there's about 20,000 DNS names for which those name servers are authoritative. So all this kind of begs the question, is the sky falling? Is this a big disaster? With so many poisoners out there, why don't we hear more about this? Well, one really good thing is that even the vulnerable implementations do not allow the root zone to be poisoned. So that sort of cuts out a big percentage of the poisoners that we see out there. But for the others, it's clear that that a name server cache can become poisoned, and that they are. So then it makes me wonder, if your name server was poisoned, how would you know? And the most obvious way I can think of that you might know is that if you're browsing the web and you go to some site and you get back bad information, what does it look like in your web browser? So we simulated that. For every bad referral that we found, we put the bogus name server's address in resolve.conf. We open up a web browser and request google.com and microsoft.com, and then we took a screenshot. So here's some examples of some of the screenshots that we got. Note that in the location bar, the URL there says www.google.com. And on the HTML page itself, it says www.google.com. This page is parked free, courtesy of GoDaddy.com. So one thing that this makes me think is that this name server, which is listed at the top there, probably has a wildcard and answers any query that you sent to it. And then the CGI script or whatever is configured to insert the name that was queried for in the HTML there. And here's a sort of a similar example. Again, it says Google in the location bar. We recently registered our domain name at namescout.com. What's also interesting about this one is that they're displaying some Google AdWords here, and it also appears that the contents of those Google AdWords are related to Google itself. So they've asked Google for AdWords about Google, and they got all these links about search engine submission and so on. Here's another example, very similar, not really too remarkable, except for the fact that in this one the location URL has changed, so there's probably been an HTTP redirect involved here. Here's a case where the name server did not provide an answer for our query to www.google.com. And this is actually quite common. A lot of the screenshots look like this. It just says unknown host. So in this case, you would definitely know, well, you should be able to figure out that something's wrong with somebody's DNS somewhere. Here's a case where you can buy various types of pills. Another example, again, this says Google at the top, but has nothing to do with Google. This one, I think, is interesting for a number of reasons. First of all, there's this annoying shockwave download pop-up in the middle. Also note that the location bar URL has changed a little. It says google.com/start.php. Notice also that on the right side of the screen there's some images. There's supposed to be some images. Those didn't come through. The server returned an error for those requests. But perhaps most interestingly, the content of this text down here talks about how Vint Cerf is coming to speak at the domain roundtable, and the guy who runs the site is very excited because he wants to meet Vint Cerf, and he's the executive event director of this domain roundtable event. So this is a guy that you would definitely think should know better than know how to configure his name server. Here's one where you can go and configure your PowerSite system for google.com. This one says, smart people choose pear neck, and I sort of beg to differ. I like this one because, if you're not the type of person that uses Google every day, you might look at this and you might think that it actually is Google. It looks sort of like what you'd expect. It's a find it bar with a search button and some other things, and the little tagline there says, "We search so you don't have to." That could very well be Google's model for all my mother knows. And this is the last one, and I like this one because it says, I don't know if you can read the text, it says, "It has been brought to our attention that the IP address of this server is being used as a local DNS resolver by a cable or a broadband provider somewhere. This is a mistake because this server reports the same IP for all queries to an internal application that has nothing to do with you. You need to contact your access provider, whoever they are, and get proper DNS resolvers from them." But what's actually happening here is the guys running this site and this name server are poisoning other people's DNS caches, and that poison is causing them to come to this site. So they're aware that something is wrong here, but they haven't quite figured it out. And I actually sent email to these guys a few days ago, but I didn't get a response back. Okay, so sort of the last thing that I want to talk about is, why is this happening? Is this people being lazy, being stupid, or are these people being truly evil? So I tried to define these categories for you. Here's an example of what I would call laziness. The name server here is, in this example, is ns1.hi2000.com. And what it looks to me like is the administrator is too lazy to put each of the zones that they've been delegated into separate zone files. And give them their own, ideally each zone should have its own file and own SOA record and so on. But instead they take a shortcut and they create a zone called com, and then they put each of their delegated domains into their com zone and just lists one or two A records. And I have an example on the next slide. And this kind of thing is probably the source of most of the DNS poisoners that we've found. Now, just looking at this example, you may not come to this conclusion, but if you go to this database that you'll be able to see it in a bit, you'd find that there's a lot of, this particular name server, is authoritative for a lot of names, and not only do they poison .com, but they also poison .net for .net names that for which they're authoritative. So here's my guess at what their zone file probably looks like. They have an SOA record for com. They list their own name servers after that. And then they list A records for their .com delegations. How much time do I have? You think I'm doing good, right? Okay. Here's an example of what you might call stupidity. In this case, it looks like there's two things going on. One is the com zone technique is being used again, where delegated names are put into a incorrect com zone, but there's no dot after the NS record name. So this response shows that for the com zone, the authority servers are ns1.com, ns2.com, and ns3.com, which have nothing to do with ns1.frakes.net. There's an additional section here which shows IP addresses for ns1.com, ns2.com, and ns3.com. Now, if you go to an unpoisoned name server and query for ns1, 2, and 3, you'll get different addresses, and you'll find that those three name servers belong to entirely different organizations. They're unrelated. This kind of example is rare, but there are actually a lot of cases where you see the mistake that there's no trailing dot after the name on the NS record. So for evilness, I actually had a hard time finding an example where I could definitely say this is somebody being evil. My definition of an evil poisoning name server is one where it answers queries that it shouldn't be receiving. It answers with the wrong IP address. So if you queried for Google, you don't get Google's address, you get something else. And it also maybe proxies web traffic so that you still get what you expect in your browser. So to help find these kind of things, I came up with this very simple ranking. And for every poisoning name server, it gets a rating from 1 to 5. 1 point each for returning a bad referral, that is just being in our database, poisoning a TLD versus poisoning the root zone, answering an A query for one of the quote, high-profile names that we queried, answering the query incorrectly gets it another point. And then finally, if the screenshot that we take looks like the real thing, then it gets another point. So we found a few name servers that are rated at 4, but so far none that have been rated at 5. A few miscellaneous notes here. Some of the sources of poison that we found are actually authoritative and vulnerable name servers. That is, they're authoritative and they're running, say, Microsoft Windows, that have been already poisoned by somebody else. Probably they, in addition to being authoritative for some zone, they're also used as caching resolvers for clients and whatnot. So those clients have poisoned the zone, and when we hit them, they return the bad referrals and the poison. I'd just like to emphasize that having an authoritative name server accept recursive queries is an incredibly bad idea, and this is a perfect example of why. Some of the NS records that we found during our survey the names are not fully qualified. The name NS is particularly popular. So that's sort of interesting, because if a caching name server becomes poisoned with a referral to a name server called NS, it's not going to be able to look up that name, and sort of the poisoning will not succeed. And it's a very good thing, I think, that even the vulnerable name server implementations don't allow the root zone to become poisoned. Here's kind of the bottom line. At this point in time, there are currently several hundred misconfigured name servers out there returning bad referrals that can poison DNS caches. Some of those perhaps with malicious intent, but I would say most do not. About 75% of those try to poison the root zone, which usually has no effect. I'm not aware of any implementations that allow the root zone to be poisoned, but that doesn't mean that there are some obscure ones out there. Probably 90% of the caching name servers out there today are running software that is not vulnerable to this kind of thing. And I would say that most of the attempted poisoning, or most of the cases where it looks like poisoning is going on, can be attributed to laziness and stupidity. Here's the URL for this online database that we have, and feel free to ask me questions after the talk or later on during the meeting. And if you want, please send me some email, and we can talk about this some more. Thanks.
Brander with River Domain. 2 questions. What do you do with these poison name servers? And do you report to abuse department, or do you actually black hole them? And B, how often you run these scripts to avoid false positives?
Well, right now I don't do anything with the information that I find, except for put it in this database, which is accessible on that URL. I did contact one technical contact for one of the cases that I found, but I didn't get a response from them. And this has been talked about before. I think in the past, contacting people is pretty hit and miss. A lot of times you just don't get a response. But it's certainly something that should be done. For the second question, what was the second question?
How often you run the scripts to
Oh.
prevent false positive?
Right. So I've run this survey a few times in the past, but not regularly. My plan is to say run it every month now, from now on. It takes about 10 days to go through the whole list of names that I have at this point. False positives is not. I wouldn't consider false positives sort of in the data. I would say, yeah, things change over time, and they may
Probably
fix their.
overblocking.
Yeah,
someone-
yeah. And it's certainly possible that someone fixes their thing and it gets taken out of the next result set.
Probably I'll ping you offline. Maybe I can help.
Okay.
Okay.
Yeah. Thank you.
All right. Thank you.
Okay.